In this lecture, we're going to go over fractures, and we're going to just talk about how do we characterize a fracture of a bone, and also we're going to talk about how does that bone heal. Bones are actually really good at healing, and that makes sense. Think about it from an evolutionary standpoint. If you are an animal that is out in nature and you break a limb, you are going to be completely vulnerable to attack. Or not be able to get to food, depending on where you fall in the food chain. Evolution has made bones heal rather well and quickly and efficiently. Way better than connective tissue. So if you remember back to the tissue unit, I talked about the fact that ligaments and tendons are going to take much longer to heal than a bone, and that is because of blood supply. Our bones have a very large blood supply because it's living tissue, right? If you've ever broken a bone before, you know it bruises extremely badly. That is one of the #1 ways you can tell if you broke a bone. You know, you can't move it very well, and also if it's very swollen and bruised, that is a good indication that something was broken. So what we're going to do is I'm going to go through the different types of fractures and just how they're characterized, and then I'm going to talk about how a bone actually heals. So let's get started. So a fracture just means a break to the bone, and that could be something that is serious where the bone is destroyed essentially, or it could be a minor fracture where the bone heals rather easily and there's not a whole lot that needs to be done. So let's go through them. The first type of fracture is called a green stick fracture, and this is an incomplete break on a convex surface. So let's talk about convex for a second. Convex means rounded outwards and concave means rounded inwards. So when you look at a bone, which I have right here, right? So if this is a femur bone right here, the convex surface would be the rounded surface on the outside of the bone. So this would be a break that occurs to the convex surface that is an incomplete break. The reason why it's called a green stick fracture is because if you've ever taken a branch that is off of a tree that is still green, meaning it's still alive, and tried to snap it, it never snaps completely. It might shred on one side, but one side will stay intact. So if you take a look over here at these images, this would be the green stick fracture. So you can see that fracture is on one side of the surface and it is an incomplete break. This is one that usually, you know, if it's a clean, you know, if it's a decent break and you're able to reset it, that is not a serious break usually. It should heal up. It depends how bad it is, obviously. So a green stick fracture is going to be one that's an incomplete break on the convex surface. A fissured fracture, on the other hand, this is one that a lot of you have probably experienced, also called a stress fracture. So a stress fracture usually occurs because of some impact or stress on the bone, and that is going to be an incomplete break, meaning it doesn't break completely through the bone, on the longitudinal. So what that means is up and down. So this will be a break that occurs on the longitudinal surface or the break of the bone, and it's going to be an incomplete break. This is a break that probably doesn't need to be treated. If you were to have a stress fracture, you know, if you've ever had one before, you know you have to just stay off of it. But you probably don't need to get it put in a cast or anything. So that's going to be a fissured break. So green stick is an incomplete break on the convex surface. Fissured means an incomplete longitudinal or up and down break, and that's caused by stress. Then we have our next one, which is a bad one, and that is comminuted. And comminuted means that it broke into fragments. So this is like a complete break where the bone breaks into fragments. This would occur from a high impact event. So if you take a look here, this is an example of what a comminuted fracture would look like. And that occurs, and that would be an issue where if you've ever heard someone say they had to rebuild the bone, the doctor had to pin the bone in place, that would be a comminuted fracture, and that is obviously going to be a very serious one, and one that would have to be treated. And then we get into some of the breaks that are going to be a little cleaner, and these down here are the, well, some of them are worse than others, but the first one is a transverse break. If you remember, transverse essentially means horizontal, right? It's that horizontal plane. So this is a break that occurs at a right angle. So something that came in and broke that bone at a right angle causes that bone to snap in a clean way. So if you take a look here, you can see this would be at a right angle, and that would be a very clean break that ideally this would be one that would probably be relatively easy to set and wouldn't cause too many problems in terms of healing, because as long as it's set right, it should heal correctly. Then we have one that's a little more serious, which is called an oblique fracture. And this would occur at an angle other than a right angle. So let's say you're standing and something falls on an angle. So something falls down on your leg and it snaps it. That would be what we call an oblique fracture. So you can see it forms at an angle. And what this would often lead to is something called a compound fracture. And that's not on the slide, but what a compound fracture is, that is when the fractured bone breaks through the skin. And that is a serious injury because once you break the skin, infection becomes a serious issue. So a compound fracture means it broke through the skin, and a simple fracture means that it did not break through the skin. So if you have an oblique fracture, if you take a look at that angle there, you can see that could easily break through the skin. And then finally, we have a really rough one, which is a spiral fracture. And that occurs when there's a twisting of the bone at the same time there's a break. So when would this happen? This would happen most likely when somebody's coming down on their leg and they're rotating. So it would break and twist, and that would most certainly cause a compound fracture. There's a lot of really gnarly videos online. If we were in class right now, maybe we'll watch some over Zoom once I get done with this. But there's some really rough looking breaks. Kevin Ware, you've probably heard of before. There's a couple really rough ones. Basketball players have this happen a lot because they jump up, and when they land, as they're landing, they twist, and then that snaps the bone. So those are the names of the fractures. Now let's go into the actual fracture repair. I'm just going to explain the steps to you, and then we'll move on from there. So as I said, nature developed a really good system for a fracture repair. When you break your bone, you know this if you've ever broken a bone before, it only takes maybe 6 weeks to heal usually, where you're back on it. And in most situations, when that bone heals, it's actually going to be in the same level of strength and ability to be used as before it broke. It heals really well. So let's get started. There are 4 stages to fracture repair. You can see this diagram right here. I'm going to explain each of those 4 stages, and then that'll be it. Okay, so let's run through them. The first stage is called a hematoma stage. And one thing that is true of your bones is they have a lot of blood vessels. It's actually where blood gets made, right? That's where our blood cells get made. So it makes sense there's a lot of blood there. And when you break a bone, you're obviously going to also tear through a blood vessel. So the first thing that happens when there's a bone break is that there's something called a hematoma. Heme means blood, and that refers to, a hematoma is just a bleeding. That's all it means is hematoma. So this is a large hematoma that forms. Those blood vessels break. Now, why would that be a good thing? Well, in order to heal, you need blood. Blood brings white blood cells. Blood brings healing proteins to stop cause clotting. So blood might be a bad thing. You might think bleeding is bad, but bleeding actually causes healing. It brings the healing elements that you need to the injury. So the first thing that happens is you're going to have this ruptured blood vessel, which leads to a hematoma. That is immediate. So usually you can tell when someone broke a leg, or a bone, I should say, if there's immediate swelling, it starts to swell up like crazy, and you see a lot of bruising. Now, here's where things start to heal. So the second stage, which usually happens within the first few days, it starts, and then this goes into the first couple weeks. But we get what is called the fibrocartilage callus stage. So what ends up happening here is you get a little bit of spongy bone forming because osteoblasts are going to come into the area through the blood vessels. You're going to get some new blood vessels forming, and you're going to get osteoclasts forming some bone right here. And you're going to get some spongy bone forming near the blood vessels. And then something kind of cool happens. And this is where, this is one of those situations where I just think it's so awesome how well constructed living things are. And this is one of those situations. So what ends up happening is you get this thing called a callus forming. It's called the fibrocartilaginous callus. And what you end up getting, if you've ever broken a bone before, usually you get a bump where that bone is broken. And that's what you're seeing here. This is that callus right here. Why would there be a bump? Well, because if you had to put your weight on that bone, you need something to support it. So the first thing that forms here is you get, within the first few days to weeks, you get what is called the fibrocartilaginous callus. Fibrocartilage starts to form here. It's not hyaline, it's fibrocartilage. So why would it be fibrocartilage? Because fibrocartilage is tougher. If you remember back to that connective tissue unit, it is a tougher, stronger collagen, and that is going to support that bone. So imagine a deer that breaks its leg. A deer can't go to the doctor and get a cast put on. So what it does is it has this fibrocartilaginous callus, which acts kind of like a support system to support that bone while it's healing. So that is that second stage, which is called the fibrocartilaginous callus stage. And you get this callus forming to the outside, and you get some spongy bone forming in the middle. The next phase is called the bony callus phase. And this takes, now we're getting into like 3-4 weeks into healing. At this point, this bone has started to heal. And what ends up happening is, just like in ossification, the cartilage dies, the chondrocytes leave those open lacunae, and osteoblasts come in and start converting that cartilage to bone. So the third step of this process, the third step of the stages, I should say, of this process is called the bony callus phase. So that cartilage converts to bone, and you get this new bone that forms where the break is. And then the final stage, which again, this is just so cool to me that I don't fully understand how these cells even know when to start and when to stop, but it's all by chemical triggers. But the last stage is called the osteoclast remodeling stage. What ends up happening is osteoclasts come in and they remodel that bone. They wear down that callus back to normal. So when you're done, you end up with a new bone that looks just like the original bone. So just as a quick review of these 4 phases, or 4 stages of bone repair. The first stage is the actual break occurs and you get what is called a hematoma. And that is just a break of the blood vessel and you get swelling at the part where the bone broke. And that's the good indication that you have broken the bone. The second stage, which is usually within the first few days to the first weeks, is going to be this stage. You're going to get what's called the fibrocartilaginous callus stage, where you have bone forming, some spongy bone forming near the blood vessels, but as you go out towards the outer portions of the bone, you get this fibrocartilage forming. And that is chondrocytes come in and they form that stronger version of collagen, which makes fibrocartilage, and it forms this callus, which is going to be this kind of enlarged collar around the break, which supports the bone while it's healing, because in nature, animals don't have the ability to get a cast like we do. There's no such thing as, you can't give a couple crutches to a squirrel that broke its leg. It's got to make that happen on its own. And then finally, we have our last 2 stages. The bony callus stage, that is when it starts to convert back into bone from cartilage, and we've already explained that, so I don't need to go in detail on that. But the chondrocytes die, they leave behind their lacunae, and osteoblasts come in and convert that cartilage to bone. And then the final stage, osteoclasts come in and they wear that bone down back to its original shape. Thank you very much.